Welcome to this new Inside Code video where we will see the main swaps to make palindrome problem. So what does the problem say? It says, given a string str made of lowercase alphabetical letters, create a function that returns the minimum number of adjacent swaps so that it becomes a palindrome. If the string can't become a palindrome, return -1. You can pause the video if you want to try solving it. First of all, we need to understand what is a palindrome. A palindrome is a string that reads the same way back and forth, race car for example, and one particularity of palindromes is that letters are kinda mirrored. You can see that the first letter is equal to the last one, then the second one is equal to the penultimate one, and so on. And this is what we will try to do with our string to make it palindromic. For each letter from the left, we search for an occurrence of it from the right, and we keep swapping to take it to the right place so that letters become mirrored. Let's do it with this string. We put two pointers left and right on the extremities and we start. The first letter is A, so we will try to find an occurrence of A from the right. And to not lose the actual value of right, we will use another pointer, called searcher for example, that starts from right. Now we keep moving searcher backward until we find the letter A. Not this one, 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 and here we finally found the letter A. Now the second step of the iteration, we keep swapping until we take it to right index, because letters must become mirrored, so the letter on left index must be the same as the one on right index. The problem says that we can only perform adjacent swaps, so we cannot directly swap with right index. We have to perform this swap, then this one, then this one, this one, this one, and this one. We finish this iteration, so we move left forward, right backward, and we repeat. Now we have to search for the letter B. Here we found B, so we take it to right. Next iteration, we search for the letter A. And we take it to right. Next iteration, we search for the letter E. Here it is, but you can see that searcher is equal to left, which means that in reality it's the same occurrence of E. We didn't find another one. Is there a problem? Not really, because a palindrome can have a center letter like E in the word race car. We don't need another occurrence of it. But two things to know. First one, we said that it's the center letter, so we now have to take it to the middle of our string. And we set it to uppercase so that the next time we find an uppercase letter, we know that it's the center letter. It's like a VIP. Second thing, a palindrome can only have one center letter. In other words, we can have only one letter whose number of occurrences is odd, which means that starting from now, if this case happens again, it means that the string cannot become a palindrome. We return -1, because in a palindrome this case is allowed only once. We continue, we now need to search for the letter C. We go to right once and we find it. We swap once and we took it to right. Next letter, D, we already have D in right index. Next one, C, same thing. Next iteration, left and right match, so we finished our work, and we got that the number of required adjacent swaps is 21. Before moving to the code, please take some seconds to like the video and to subscribe to the channel, if you want to do so obviously. Okay, now let's move to the code. First of all, strings are immutable in Python, so to facilitate swapping between letters, we first convert it to an array. Then we need the variable that will count the number of swaps. The left pointer is starts at the first index, the right pointer is starts at the last index, and a boolean variable found center that tells us if we already found the center letter. This boolean is very important because we said that we're allowed to find only one center letter, so once we find it, we set this boolean to true so that the next time we find a letter that has no second occurrence, we return -1, except if it's uppercase because it would mean that it's the one we found earlier. The loop gets repeated while left and right didn't meet or left exceeded right, so we write while left is smaller than right. Inside the loop, we create searcher pointer, it starts at right, then while we didn't find the same letter as the one at index left, we move searcher backward. Now that we found the position of the letter we're searching for, we have two cases. Either searcher found another occurrence or it stopped at left index. If it stopped at left index, we also have two cases. We said that we're allowed to have only one center letter. So if we already found the center letter and it's not the one we're actually in, it means that the string cannot be a palindrome. We return -1. We can know if we are in the center letter by checking if it's lowercase or uppercase. Else, we put our boolean variable to true because we found the center letter, we calculate the middle index by dividing str length by 2, then we take the letter to the center while counting the number of swaps we did. To perform a swap, we swap between str of searcher and str of searcher +1, and we increment searcher. After taking the center letter to its right position, we set it to uppercase to be able to recognize it later. Else if we found a new occurrence, then we don't have the center letter problem, we just need a while loop to take the letter to right index. So we write while searcher isn't equal to right, we swap between str of searcher and str of searcher plus 1, we increment count, and we move searcher forward. After it, we move left forward and right backward for the next iteration. Then after finishing all iterations of the outer loop, it means that our string is now a palindrome, we just return count. Okay, now we made the function to get the minimum number of swaps when you keep searching for the letter at index left. But you have to know that it's sometimes better to do it from the right. Let me give you an example. We have the string CAABB. If we keep searching for the letter at left, we'd need 6 swaps. But if we do it from the right, we'd only need 4 swaps. And to do it from the right, we don't need to write another function. We just reverse the string and we call the function we made. So the idea is that in our solution function, we get the minimum swaps when we traverse from left, the minimum swaps when we traverse from right, and we return the minimum among them. That's it. Let's move to complexity analysis now. For the time complexity, we are traversing letters of str, and we are kinda retraversing it each time to search for the letter then take it to its right position. This gives us a time complexity of of n squared, where n is the length of str. And for the space complexity, we are using an array to store characters of str, so the space complexity is O of n. I hope that you enjoyed this video, please comment below what you thought about it, and see you in the next one.